Natanz, Iran. Underground. 6,000 centrifuges spin in the dark, screaming at supersonic speed, refining uranium no one is supposed to see. The engineers on shift watch their screens. Every number is green. Every reading is normal. But 3 floors down, metal is failing. A centrifuge shudders. Then another. Then a third. Tearing itself apart from the inside. Spinning faster than physics allows. Faster than any human command has told it to. The operators stare at their monitors. The monitors tell them nothing is wrong. They are already too late. They just don't know it yet. This is 2010, and the machine tearing itself apart isn't broken. It's being murdered, one line of code at a time. Somewhere, a weapon has been built. Not with steel, not with fire, with software. And it has just done something no weapon in human history has ever done before. It has crossed from the digital world into the physical one and left no fingerprints. This is the story of Stuxnet, the first cyberweapon that ever worked exactly as designed. A weapon built to destroy a nuclear program without a single soldier crossing a border, without a single missile leaving a silo, without the target even knowing it was under attack. To understand how it happened, you have to go back 4 years, to a room full of engineers with an impossible problem. Iran's nuclear facility at Natanz was buried under meters of reinforced concrete, air-gapped, isolated from the internet by design, because everyone building it understood the first rule of hardened security. If it's not connected, it can't be hacked. So the attackers didn't try to break in through the internet. They broke in through people. Intelligence operatives believed the weapon was smuggled in on infected USB drives, carried, knowingly or not, by contractors and engineers who plugged them into machines that were never supposed to touch the outside world. Once inside, the code didn't announce itself. It didn't crash a single system. It waited for weeks, sometimes months, quietly mapping the internal network, searching for one very specific target. A piece of industrial control software made by Siemens, used to run the exact centrifuge cascades hidden inside Natanz. Most malware at the time was noisy, loud, built to spread and be seen. This was the opposite. It was built to disappear. And to disappear at this level, it needed something almost no cyber weapon had ever used before. Zero-day exploits, security flaws in Windows that nobody else in the world knew existed. Not one, not two. 4 of them burned in a single operation. To put that in perspective, most attackers spend years hoarding a single 0-day like a bullet they only fire once. This weapon spent 4 in one shot because the target was worth it. Then came the part that made it a weapon, not just an intrusion. Once Stuxnet found its target, it didn't just corrupt files or steal data. It rewrote the commands going to the centrifuges themselves, subtly increasing and decreasing their spin speed again and again, stressing the metal past its tolerances, grinding the machines toward failure from the inside. And at the exact same time, it recorded weeks of normal operating data from the plant, then played that recording back to the control room operators on a loop. A digital forgery, a puppet show. The engineers watching their screens saw calm, steady numbers, green lights, normal readings. The centrifuges spinning in front of them were dying. For months, Iranian engineers were baffled. Centrifuges kept failing, quietly, one by one, at a rate that made no engineering sense. They fired technicians, suspected sabotage from within, replaced parts, replaced people. The failures continued. They were debugging a machine that was lying to their faces, and they didn't even know it could lie. The weapon might have worked in silence forever, if it hadn't made one mistake. An update pushed the code slightly too aggressively. It began replicating faster than intended, slipping past the air gap it was designed to respect, spreading onto internet-connected machines far outside Natanz. Suddenly, computers around the world were reporting the same strange infection. Security researchers at a small Belarusian antivirus firm found it first in June 2010. They didn't know what they were looking at. Nobody did, not immediately. But the more they dug, the stranger it got. This wasn't ransomware. It wasn't stealing bank details. It was searching specifically for one piece of industrial software that controlled one very particular kind of machine. It took months of forensic work by researchers around the world to realize the horrifying scope of what they'd found. A cyberweapon precision-built to physically destroy a single facility on the other side of the planet. And it had been operating successfully, undetected, for over a year. By the time it was fully exposed, Stuxnet had already destroyed close to 1,000 centrifuges and set Iran's uranium enrichment program back by an estimated 1 to 2 years. No missiles, no casualties, no declaration of war, just code that reached through a screen, into a machine, into the physical world, and broke something that was never supposed to break.